Secondly, I'm going to give you an outline of the story. So part of this talk will give you a sort of brief history of the universe, but this audience, I think, already knows a lot of that history. So if I move quite fast, it won't be a problem, I hope. Then third, I want to focus on the place of humans in this world. And I'll argue that our role in the history of planet Earth is fundamental, absolutely fundamental and critical, and that young people need to understand that. And I'll end by mentioning some resources on big history today. So, let me start with the idea of a modern origin story. So, what are origin stories? By origin stories, I mean stories that try to bring together everything that is known in a particular community and bring them together in a form that is teachable and engaging so that knowledge can be passed on from generation to generation. Now, as far as we know, all human societies have taught origin stories. They were probably being taught 100,000 years ago in Paleolithic communities in Africa. They lie at the heart of all the great religious traditions, at the heart of Christianity, Islam, Buddhism, Confucianism, all these traditions. At their heart, there is an origin story. And what they do is they bring together all the knowledge of that society, and they provide a sort of universal mapping so that you can identify your place in time and space. So you can say, this is what I am, this is who I am, this is what I'm part of. The trouble is that modern schools don't teach such a story. And I actually think that's dangerous in all sorts of ways. It creates what the sociologist Emil Durkheim called a sense of anomie. And Durkheim's first book was on suicide. And he argued that anomie, not knowing what you're part of, not having a map that you can put yourself on, can drive people to suicide because it deprives them of a sense of meaning and purpose. So having these maps is immensely important. Modern schools don't teach them, and I think that's a very dangerous thing. They fail to teach us what we're part of. Let me try to, here's a very simple graphic that I hope gives some sense of what I mean by the mapping. And I think it's something that, again, is familiar to every Montessori teacher. So we have the self. At the center is the self. But the self is part of a family. You identify with a family. Then beyond the family is the village or clan or maybe the workplace or the school you work for. Then beyond that is your nation or your religion or your civilization. Now that is an identity that modern schools teach very well. Every school everywhere in the world teaches you about your national identity and the history of the national community you belong to. And I have to say that personally, I think it's time to move on from that community, because in a world with nuclear weapons, it seems to me, and I remember the Cuban Missile Crisis as a school kid, it seems to me crazy in a world with nuclear weapons to be telling young people that their primary commitment is to their nation. Beyond the nation, there is the next identity. I'm struggling a bit with this. Sorry, I'm struggling a bit with this pointer. It's not always moving. Beyond the nation, there is the identity of humanity, the community of humanity. Now, that is not an identity or a community that we teach about. I don't know of any school anywhere in the world that has, or university that has courses on the history of humanity. And yet, I'm deeply convinced that it's possible to construct them. And in fact, I think big history does that. To construct those histories, and they can be as inspiring, as exciting, as interesting as the great national histories. But of course, governments have very little interest in funding histories of humanity. So there's that community. Then beyond that, there's the community of the biosphere and the earth. We're living organisms. We're part of a community of billions of living organisms that has evolved over 4 billion years. The biosphere created us. We evolved from other living organisms. They are our kin, as genetics has shown us. So there's that community of planet Earth. And then beyond that, there's the universe and the cosmos. Now, all these identities are embedded in each other. And each identity can be understood more richly and more deeply and more profoundly if you see how it links to other identities. Now, there's something else that links with this. To understand all these identities, to see this mapping properly, you have to be willing to look at many different disciplines and see the links between them. So the way disciplines are compartmentalized in modern education doesn't help here. So we need to see the links between disciplines. So here's another quick, this is a very crude graphic, but I hope it makes the point. So this is the individual, there's me. I can think of psychology as the discipline that studies me as an individual. Beyond that, the sociology or anthropology, it discovers me in groups. Then beyond that, there's history or global studies, which study me as part of a global community. Then beyond that, there's biology, studies of the biosphere, the environment, earth sciences, planetary sciences that study the history of planet Earth, and then astronomy, and finally, cosmology. So to understand these different mappings, we need to understand many different disciplines and see the links between them. And again, I think modern education is so compartmentalized, it makes it difficult to see these links, and big history tries to bring out these links. Now, Carla told me that she's been using this painting for many years. I'm sure you're familiar with it. I've been using it as a sort of, I suppose a logo really is the word, for big history. So let me explain why. There's astronomy and cosmology up there in the top. Here's geology, planet Earth. There's water, so let's take that as a symbol of life and chemistry, because life evolved in water. And here we have anthropology and history. We've got buildings, we've got a city, we've got civilization, and there we have modern technology, modern science. And the missing bit, how many feel that if I put you on the spot and said, what's the missing bit? How many feel you would know the answer to this? This is not a fair question, but... Okay, so the missing bit is you and me and trying to figure out what is our place in this whole damn thing. And that's why I think Van Gogh's painting is a lovely icon for all of this. You put them all together and you get a modern origin story. An origin story for our times, and one that's based on modern science. So, how do you build a modern origin story? The idea of building a modern origin story. Now, this slide is a shameless piece of self-advertisement for my book, Origin Story, which has just come out. So many of the ideas I'm talking about here are developed in more detail in that book. But the idea of trying to construct a modern, science-based origin story that's based not just on tradition, not just on authority, but on the modern form of knowledge known as science, really goes back to the 18th century. It was very much at the heart of the Enlightenment, the idea of a new origin story, one that was better than the old ones, and that could help humans progress better than the old stories. Now, big history tries to tell this story, the history of everything, from the Big Bang to the creation of Earth, to the evolution of life on Earth, and to the history of our own strange species, Homo sapiens, and to our world. So that's the project that big history is involved in. Now, why should we return to this project today? Because in the 19th century, something strange happened. In the 19th century, many of the great thinkers still were interested in this project. I think this was a project for thinkers like Hegel, Kant, Marx, Spencer, all of these people. Now, the problem was the science was not yet good enough. So the stories they produced were very ideological, and they had some, aspects that are clearly not scientific. And that created a sort of disillusionment in the late 19th century with these big universal stories. And the second thing that happened was that there was a tsunami of knowledge that emerged in the 19th century. So in schools and universities and research institutes throughout the world, I think everywhere in the world, what happened was scholars decided that this project of building a modern origin story was too difficult, too hard. Let's break knowledge into chunks, into the disciplines. So from the late 19th century, the idea of a universal story was abandoned, and it vanished almost entirely, apart from a very few thinkers, and I think Maria Montessori may have been one of them, who preserved that idea. Oh, by the way, shameless self-advertisement, this is the Swedish edition of my book. So in the early 20th century, we entered a fragmented world without any intellectual unity, a world of disciplines, and we still live in that world for the most part. The disciplines worked. They worked superbly because within each discipline, fantastic work was done. And in the 20th century, the details of a modern origin story were developed with incredible richness. So much so that now, early in the 21st century, I think the science is so good that we can tell this story and we can tell it rigorously. But in the 20th century, we lost the idea of a unified origin story. And that's why today we still live in this world of fragmented knowledge. And I know this from personal experience, and I'm sure you know this, trying to persuade many people that you can teach a history of the universe, many people find it laughable because we live in this fragmented world of disciplines. But it's now not laughable. It's something we can do, and we can do it very well because the science is so much richer. Big Bang cosmology, plate tectonics, modern understanding of genetics, all of these things mean we can tell this story very well. And in fact, we need it to understand today's world. E.O. Wilson argued that in the fragmented world of disciplines, there are huge numbers of problems that lie in dead zones between the disciplines, and we never look at them. And some of those problems are some of the biggest problems we can face, such as climate change in various forms. Okay. So, if, like me, naively, 30 years ago, I thought, I think we need to put together a unified modern origin story, how do you do it in a world of disciplines? Well, I'm a historian, so my approach was a sort of storyteller's approach. I thought, I'll talk to the cosmologists, I'll talk to the astronomers, to the geologists, to the biologists, to the historians and the anthropologists, and I'll get all their stories and just put them together like a quilt. And let's see what emerges. And I thought naively that a unified, a modern origin story would emerge if I just put these all together. So here's me telling a story in Tianjin a few years ago. I invited at my university lecturers from many different disciplines, and I was saying to them things like, I'm starting a course on the history of everything. Do you think you could come along and give a lecture that summarizes your entire discipline in 1 hour for my students? And many people said, no, I don't think so. That's not the way we work. But some people, God bless them, said, yeah, I'd love to do that. Sounds like a lot of fun. So we got great lectures. And I sat through all these lectures, cosmology, astronomy, geology, biology. But there was a problem. Each lecturer brought their own jargon, their own concepts, their own ways of thinking, their own paradigms. And for my poor first-year history students, this was a nightmare. They really couldn't. So when the geologist says, so there are metamorphic rocks, my students are thinking, what? What is a metamorphic rock? They had no idea. So at first I thought, no, this is not going to work. It's going to be like a quilt. There's no coherence. But then something quite magical happened. Over several years, the students loved it. And then over several years, I watched all these lectures, and gradually, I don't know if many of you remember an old-fashioned photographic darkroom. You expose a white sheet, you put it in the chemicals, and then gradually, beautifully, a picture emerges on this white sheet. Well, that's what happened to me. over several years, the story began to emerge. So now I want to try and tell that story, or give you a feeling for it, very briefly. The story has a plot, as all stories should. And in the way I tell it, and it's not the only way, the central part of the plot is the idea of increasing complexity. The early universe was very simple. So think of a thin mist, a sort of fog of hydrogen and helium atoms. No other chemical elements, no gold, no iron, none of that. There's photons of light pouring through it. There's dark matter, which we don't understand. There's dark energy, which we don't understand. So this whole thing's very smooth, very homogeneous, doesn't have much structure. It's very simple. We can study it, by the way, by studying the cosmic background radiation. And what we find is the difference between hot areas and cold areas is about I believe it's 1,000th of a degree or 100,000th of a degree. If there are cosmologists in the room, you can correct me. Very homogeneous, very smooth. There are no galaxies and stars, there are no planets, there are no heavier chemical elements, there are no living organisms, there are certainly no smartphones and things like that. Then, and this is the magic of the story, over 13.8 billion years, environments appear within the universe that I can think of as Goldilocks environments. In those environments, more complex things appear. And they appear at what I call threshold moments. And the way they appear is that things that already exist are rearranged in new ways to create new structures that have new emergent properties. And what the story focuses on is these moments in which new complex things appear. Now, we need to be clear, most of the universe is still very simple. If I picked you up and threw you into the universe randomly, the odds are overwhelming that you would find yourself in a place that was cold, empty, you couldn't breathe, you wouldn't survive long. But there are these special places, Goldilocks environments, such as the early Earth, which was a beautiful Goldilocks environment for complexity, where new and complex things appear. And this is a story very much about us, because we live in this fantastically complex modern world. So to understand our world, we need to understand how step by step more complex things appear, and each step contributes to the next step. The story has a villain. The bad guy is entropy. Actually, I know an astrophysicist who said, David, you got this completely wrong. He said, entropy is not the villain at all. Entropy is the good guy, because actually entropy allows the energy flows that create complexity. He's probably right, but I'm going to go with the idea of entropy as a bad guy because it's much better for the storytelling. So, okay, entropy. This is the tendency of everything to deteriorate, to degrade, the tendency of all structures to break down. So that creates a puzzle. If the second law of thermodynamics, and that's what we're talking about, is one of the most fundamental laws in physics, how is it possible for more complex things to be created? I hope you see this as a very deep problem. It's a problem about us. How is it possible for an environment like this to emerge with fantastically complex organisms like us? How is it possible? Well, I'm not sure that we have yet a perfect answer, but let me just try two possible answers. The first is that at the Big Bang, this moment when something appeared smaller than an atom that contained everything that's in our universe, at that moment, some rules appeared at the same time. And they said simple things like there will be a force called gravity, and it will pull everything together. The fundamental laws of physics. So that guaranteed that the universe would not be pure mush, pure chaos. There would be some structure in the universe. And the second thing is that complex things always depend on flows of energy. If you see complex things, you can always ask yourself, what is the flow of energy that enables this thing to exist? And those flows of energy, the more energy flows, the faster that energy degrades. So you can imagine entropy in the background looking at a city like Oslo and looking at all that waste and all the energy and the carbon dioxide pumped into the atmosphere and thinking, great, it's all breaking down. So complexity is doing entropy's work. Okay, now a timeline for the story. What is the story? In my book, I have a series of timelines. So let me just explain how these work. I'm not going to go through all of this. On the left, we have a number of thresholds. There are 8 in the way I tell the story. The first is the Big Bang. The second is the first stars. The third is the creation of new chemical elements. The fourth is the creation of planets and moons and asteroids, planets like our Earth. Okay? Here in the second column, I have some rough absolute dates for when these things first appeared. Now, this third column, what it does is divide all the dates by 1 billion. And the reason for that is that we humans, our brains are not designed to manage ideas like 1 million years or 1 billion years. We don't need brains that can deal with that because none of us is going to live for 1 million years. I mean, I hope I don't. So we need help. And what this does is creates a timeline that is more manageable for us. So let's imagine the universe was created 13 years, 8 months ago. That means that, for example, our sun and solar system were created 4 years and 6 months ago. You can probably remember where you were 4 years and 6 months ago. So that's how it works. Now, I'm going to give you an example of how a threshold works, how more complex things appear. So, and I'm going to take threshold 2, star formation, and just very quickly describe how this works. So, remember that early universe with the thin mist of hydrogen and helium atoms and energy pouring through it. No real structure at all in that universe, except at the detail, where you have atoms and you have protons and you have electrons. So, how do you get from that to a more complex universe? Well, the key actor here is gravity. What gravity does is pull things together. So this smooth early universe slowly breaks up into clumps of hydrogen and helium atoms, gazillions of them, billions of them. And each clump gets denser and denser and denser as gravity pulls it together. And as it gets denser, they heat up, atoms collide, they break up, things get hotter and hotter and hotter, until eventually things are so hot, and remember, this is while the rest of the universe is cooling down, that protons start to fuse together. Now, that's what happens inside a hydrogen bomb. So when protons fuse, some of their mass is turned into pure energy. There's a huge release of energy. So imagine each of these clouds, it's getting compressed, billions of them. Then suddenly at the center, fusion begins. So suddenly there's a furnace at the center pushing back against gravity, and the whole thing sort of stabilizes. And it'll stabilize for several billion years. It's like a hydrogen bomb that's going to keep exploding for several billion years. That's what our sun is. So you can think of gazillions of stars lighting up, beginning about 500 million years after the Big Bang. And a universe with stars is already much more interesting. It's got structure, it's got shape, it's got differences of temperature, of density, of gravity. Galaxies have structure, stars have structure, they pump energy into space. So this is a much more interesting universe. So I hope you see how old ingredients are rearranged to form something with entirely new qualities. And what does it is a flow of energy. And this is the flow of energy from fusion at the center of stars. So that's star formation. And it creates a new threshold of complexity. Now, we're going to move very fast through the rest of the story. There's the first 4 thresholds. Now, threshold 5 is the creation of life. Life is very different from the other forms of complexity. And to be honest, we don't fully understand how to describe it. Living things have this spooky appearance of purpose. They seem to push back against entropy. And there are two purposes. We know exactly what the purposes are of living things. First, survive as long as you can in an unstable and rapidly changing environment. Secondly, reproduce, make copies of yourself so that if you die, they can carry on the project. And this is the basis for life on Earth and evolution. So life appears 3.8 billion years ago on Earth. It may have appeared elsewhere. We don't yet know. We could learn in the next few decades. That's 3 years, 9 months ago on this timescale. Early life was tiny bacterial, single cells. The first large organisms appear about 600 million years ago. On this timescale, that's 7 months ago. So you can remember where you were 7 months ago. 65 million years ago, an asteroid lands in what is now Mexico. It wipes out the dinosaurs in 24 hours. So this is the equivalent of a nuclear war. That's immensely important in the modern origin story, because if that asteroid had been on a trajectory 5 minutes earlier or 5 minutes later, the dinosaurs would still rule planet Earth, and you and I would not be here. We can absolutely guarantee that. So it's a very important part of our story. Humans appear about 200,000 years ago. Now, look at this. That's 100 minutes, 60 minutes, roughly speaking. So you know where you were 1 hour ago. That's when humans appear in this story on that timeline. Now, I'm going to argue that I've described this as a threshold. So here's a question. Is this a sort of species bragging? Am I simply bragging about being a human? Or is the appearance of humans really a turning point in the history of planet Earth? Now, it's a great question to raise for students, by the way. There's lots of questions here. You know, should there be more thresholds? Should there be less? But I'm going to argue that it is a big deal indeed, the appearance of our species. And then there are two more thresholds that I talk about. One is this, the appearance of agriculture. And each threshold generates new energy flows. And then is the fossil fuels revolution, about 200 years ago. So those are the thresholds. And the fossil fuels revolution is 6 seconds ago on this timeline, our final timeline. So you see how recent humans are, which makes it all the more astonishing what an impact we've had. So part 3, the place of humans and today's world in a modern origin story. Now, I don't know if some of you may be losing track of the timeline, so let's just flick through this. The universe appears 13.8 billion years ago. The yellow is the shortened timeline. The Earth would have existed for 5 years, life on Earth for about 4 years and 3 months, large organisms from the Cambrian for 7 months. The asteroid that killed the dinosaurs would have landed 3 weeks ago. You can remember where you were 3 weeks ago. Our own species would have existed for 50 minutes, an hour, something like that. No one exactly knows when we appeared. Agricultural societies would have existed for 5 minutes. States, cities, civilizations, all the things historians love to write about, existed for 3 minutes on this time scale, and modern industrial societies for 6 seconds. Okay? So that gives you some sense of the shape of the story. Now, the Earth is about 1/3 the age of the universe. Human history occupies less than 1 hour in this story. That's to give you a sense of proportion. Okay, so what is it about us humans? Now, one of the wonderful things I think about trying to put this story together is that many people say, David, this story is too complicated. No one can get their brain around it. Well, we know that's wrong, okay? And in fact, they'll say there are big philosophical questions like what makes humans different. They're so big you can't answer them. I think that's completely wrong. On the scale of an origin story, answers sometimes appear to problems that look very complex on a small scale. And I think we can say what it is that makes us different. So let me have a go at this. We're the first species in 4 billion years to have crossed a small but immensely significant threshold. And that's the threshold to what I call collective learning. So let me try and explain this. There are many brainy animals. We are very similar to chimps in so many ways, and chimps are very smart creatures. Dogs are smart, cats are smart. And many animals can communicate, but their communication system is limited. And what that means is that they can share a little bit of information, but they cannot share so much information that it accumulates across generations. So if you study the history of a chimp community, you're not going to find new technologies appear over the last 1,000 years. Basically, they remain with the same technology. Human language is so precise, and we can convey so much information with such bandwidth. Now, imagine that I had to give the rest of this lecture in mime. I couldn't convey much. Words are so powerful. Each word is like a sort of little nugget that contains compressed information, huge amounts of it. So I say the phrase pink elephant. I think I can guarantee a picture has popped up in your brains. This is the power of words. So we've crossed this threshold. We can communicate so efficiently that what I learn, I can add to the collective memory, and what you learn can be added. So over 200,000 years, humans have been accumulating information, and we're the first species to do this. And the process has got faster and faster and faster, and today it's terrifyingly fast. This is collective learning. Now the thing is that information gives you control over the resources and the energy flows in your environment. So a species that can do this will gain increasing power over its environment and over energy flows and resource flows, and eventually you can guarantee it will dominate its planet. If such species have appeared elsewhere, I bet they are living eventually through an Anthropocene era. So that's collective learning. And it's a small but tiny difference that explains why we are so powerful. So this begins in the Paleolithic. That's the range of chimps. Now, as far as we know, it has not changed in 100,000 years. Not significantly. Small ways, yes, but not significantly. Here's where humans probably evolved. We're not absolutely certain. And then what they'd start doing is moving into new environments. As they accumulate new information, they learn how to use new environments. Now, each time they do this, this means they're controlling more of the energy that flows through the biosphere. So here is a sort of map showing Paleolithic migrations, and I'll just skip through them. I live in Australia, so this one I think is peculiarly significant. 60,000 years ago, they had to cross water. When they arrived, they face entirely new animals and plants. They have to learn very fast indeed. Chimps couldn't have done that, but humans can. Up here, Ice Age Siberia. Now, can you imagine yourself living in Ice Age Siberia? You'd say, I'm hungry, I want some food. And someone would say, great, get a mammoth. I said, I don't know how to do that. But the technology emerged. And then by 10,000 years ago, you can find humans on all the continents apart from Antarctica. So what this means is that collectively, humans are now mobilizing energy from a huge array of different environments. They're mobilizing a lot of energy, and this is in the Paleolithic. And then things start to speed up with agriculture. Agriculture is a sort of energy grab by one species, and here's how it works. We go back to fusion in the sun. The sun creates energy, pours into space, it's captured by plants, and then what farmers do is they manipulate their environments. They divert rivers, they cut down trees, they plow the land, they herd cattle, and they do it in such a way as to increase the production of species they can use, and decrease the production of species they can't use. We call them pests, rats or cockroaches or wolves. But you increase the production of rice and wheat and cattle and goats. So think of the end result of this. The end result is that our species is now controlling more of the energy that flows through the biosphere, originally captured by photosynthesis from sunlight. So agriculture is an energy grab. And we've seen over and over again that increased energy allows increased complexity. So that's exactly what you get in human history. You get all the things historians love to write about. Villages appear, populations grow, towns, cities, civilizations, states, empires. More people means more collective learning. The whole process accelerates. You get new innovations, you get science, all the things historians normally study. But by 1800, some scholars, Adam Smith is one of them, by the way, are beginning to say, this is the end. We now farm everywhere on Earth. There is no more energy or resources to be had. Growth is going to slow down. The economists often forget that Adam Smith looked towards a no-growth future. Now, of course, he was wrong, but he was wrong because we discovered a new source of energy, fossil fuels. Agriculture exploited energy captured by photosynthesis within the last year, very often. If you burn a piece of wood, you might be releasing energy that was generated in the sun 10 years ago. What fossil fuels are is energy from sunlight that's been captured, stored, buried over 300 million years. Okay? So this is a colossal store of energy, and I hope this graphic gives you some sense of what I mean by saying that. That's the maximum energy consumption that Adam Smith was talking about. Now, can you imagine today's world without all this? So this is what created today's world. And see how recent this is. I was alive in 1950. So this is the increase in my lifetime. Do you get a sense of the speed up, the staggering acceleration of what's going on? And this is what built modern society, the staggering complexity of today's modern global society. And those energy flows are now so great that they match the great energy flows of the climate system, the carbon cycle, the water cycle, and geological processes. We've suddenly become a planetary force. Now, to think about this, and young people need to understand it, because they will be making the big decisions about how we cope with our astonishing and dangerous power. It helps to think of a good Anthropocene. We live in the Anthropocene epoch, when humans dominate the planet, and a bad Anthropocene. The good Anthropocene is represented by these graphics. This huge flow of energy means that each person now controls a lot more energy than we did in the past. Every time you fly in a plane or go in a car or switch on a light, I've seen estimates that each of us has the equivalent of 100 slaves working for us from this energy. So, and lives are better for billions of people. There are many people left behind, but billions of people now live longer lives, healthier lives. And I'm betting just about everyone in this room belongs to this new global middle class that's living better lives than almost any humans in the past. That's the benefit. That's the good Anthropocene. The bad Anthropocene is the fact that these huge flows of energy are disrupting the biosphere on which we depend. This is entropy. This entropy, again, is sort of, twirling his whiskers and sort of smacking his hands. This is great. Everything's going to break down, thinks entropy. Can we avoid that? Here's one illustration. You'll all be familiar with this, but you can see how this illustration of CO2 emissions tracks that graphic of energy use. This is CO2 emissions in my lifetime. CO2 is, of course, a greenhouse gas. The climate has been kept within manageable bounds for 4 billion years by fluctuations in the proportion of greenhouse gases. Today, we're suddenly messing with the thermostats, and we don't really understand what we're doing. It's very dangerous. To get a sense of the increase, here is human history beginning, here's the Industrial Revolution, and here's today. So that is the increase in CO2 emissions in the last 150 years. Let's pan back a bit further. Here's a graphic showing CO2 levels over sort of 60 million years. And there's today. There's 2005, there's 2200. Now, according to the worst predictions of the IPCC, that temperature level is close to the highest temperature levels we've ever seen in the 4 billion year history of planet Earth. So we're messing with the thermostats. That's the dangerous thing. So suddenly we're so powerful that what we do in the next 50 years, and what a younger generation, all your students, are going to be taking these decisions. What they do will shape the future of the biosphere, of future generations of humans, of other species, for hundreds of thousands, maybe for millions of years. This is a very big deal, the moment we live in right now, which is why it is so important that young people, that we try to help young people see the challenges they face and prepare them for it. Here are just 3 quick measures of how powerful we are. The changes in the last 100 years are almost as rapid as the changes inflicted by that asteroid that wiped out the dinosaurs. So here, 3 basic measures of our power. First, the impact on biosphere systems. We're transforming the climate system, the temperature of oceans, the circulation of carbon. I recently discovered we are changing how the Earth wobbles on its axis. The melting of Greenland ice sheets is redistributing mass over the surface of the Earth. That is changing how the Earth wobbles on its axis. That's how powerful we are. A second measure, destructive power. 200 years ago, the most destructive weapon humans had was probably the cannons that were used at the Battle of Waterloo. Today, we have nuclear weapons. And what that means is, if we're foolish enough, we could degrade much of the biosphere in 24 hours. Hundreds of those weapons still exist. They're on hair trigger alert. They could be used in 24 hours. That's our power, the power we have. And the impact on biomass. A recent study suggests that since humans appeared, the total biomass of the biosphere has declined by 50%. Most of that is deforestation, because trees make up a huge amount of biomass. So we are a planetary force. There should be no doubt about that. And we became one in just 100 years. This is a very, very sudden thing. So this is my nightmare. My nightmare is that someone wakes me up and says, "Captain, are you ready to land at LA Airport?" And I wake up and I look at this screen, and I look at the dials and the levers, and I think, I haven't a clue. I don't know what dials to look at. I don't know what levers to pull. That, I think, is sort of the situation we're in as humans. We don't really understand this machine we've created. Can we land it safely? That's the challenge for the people you teach and the people that I teach. Can they land this machine safely? That means in a way that leads to a good life for my children and my grandchildren and your children and grandchildren. So Big History tells this story. There are lots of resources. Big History School has just been released. It includes a junior school syllabus and a high school syllabus, and also an upper high school syllabus. The Big History Project has existed for about 8 years. It's very, very good. These are free online sources anyone can use. You just go to those websites. You can use any of the resources you want. And Big History is now being taught in lots of schools, mainly in the US and Australia. And there are now lots of books on Big History. There are lots of resources. That's Big History School. which we've built at Macquarie University in Sydney. It's very new, there's still work to be done on it, but it includes a junior syllabus. So, why does this matter? That's my son Joshua, that's my grandson Daniel. The cool one with the glasses is Evie Rose Molly, my granddaughter. They will be trying to land the plane. And we as educators need to give them whatever help we can. And my own belief is that knowing this big story is crucial to understanding the challenge they face and what they can do in the near future. So I thank you for your attention.
Please stay. We would like to. We would like to thank you so very much for being here. I can say throughout my Montessori journey, I've read about big history, and it's just such an honor that you're actually here. We were at the Nobel Peace Center to buy a gift, and we were thinking that would be appropriate. And a funny story is that when we asked what they recommended Origin Story from Big History. Yes. But we thought maybe you had that already. So it's a different book. So also in the card here it says, "Plant me, and with some care and attention, I will grow into fresh flowers." So the card is the seeds as well. Thank you so much for being here.
Thank you very much.
Thank you.
Thank you very much indeed.
And now, yes? And now we have the honor of Carla Foster being here, who is our cosmic education specialist. And she is an AMI trainer all over the world, and especially we have her here in Norway, and we are so lucky. So thank you, Carla, for being here, and welcome.
Først så hadde jeg tenkt å snakke på norsk, men fordi David trenger å vite hvordan kosmisk utdannelse bruker det som han har snakket om, så må jeg egentlig gå over til engelsk. Så jeg skal prøve å snakke sakte nok. I first ran into the work that David has done a long time ago. He became one of my secret crushes. And I told him about him to everybody I knew, along with E.O. Wilson and a few others I'm going to be mentioning that he also mentioned. And I hope that any of you who are Montessori elementary teachers, that you want to be him. Because if you don't want to be him, you have no business being a Montessori teacher in an elementary classroom. You have to want to be able to tell the stories that he just told you. You have to want to be able to enthuse your children to their innermost core, as Montessori said. And she never saw this picture. She didn't live in a time where we had this picture. And this is actually a picture of our biosphere. This is 20 years of tracking photosynthesis in the oceans and on the land. But she said, "What are you made of?" we asked the earth. The answer could never be of stone. The answer should be of life. I am made of life. What is in me is the work of living creatures. And she was very much influenced by some thinkers at the time who were trying to get back this giant cosmic origin stories. And she could, of course, not complete that work. And it's not really useful for us to be talking about, oh, well, if she were alive today, she would be doing this, she would be doing that, because she herself, near the end of her life, said, "Do not look at me. Love the universe and look at the child." And I know that that's what Sylvia talked about yesterday as well. The answers are there in the universe, and the answers are there in the children. And so we have the materials that we need to help the children understand what David was talking about. This is a simple chart, because we're talking not to high school students. We're talking to 6-year-olds. And we have this chart of interdependency, where the biosphere and its relationship to the atmosphere, the hydrosphere, and the lithosphere and the sun are described in the top, with the interdependencies of that. And then we have the human people who you saw in David's presentation, had traveled all over the world, creating these different cultures and using the resources they found in any way they could to ensure the survival of their groups. The decisions that they made were based on the places they lived and the needs of their group's survival. So whether they made good decisions, bad decisions, was really immaterial. But now, as our connectivity has grown, and we are now connected up, we are connected to that gray circle, all of the things that we have made, all of this energy grab that David talked about, which is ultimately then affecting what existed before we came. And so this chart is something that we have to bring out many times in the elementary. And we tell it, the story, slightly differently, depending on whether we're talking about human interdependency or the work of water, the work of air. But in all of it, these are the central core principles of cosmic education. That there is this law and order. There are these things we can count on, like gravity, like entropy. And that this causes these elements in our world to be in a type of harmony. And we're not talking about kumbaya, everybody's having a great time kind of harmony. We're talking about the fact that things can be different. There can be this diversity, there can be this complexity, and yet there can be unity. There's work. She talks a lot about work. She personifies the different elements in the world and makes them active agents of creation. Because we are talking to children who also need to recognize their need to work in their environment. That there is always going to be change. Things will never just stay in a static state, and that change can be difficult. Change can create conflict. Conflict is just about things just not matching, and it is not something to be afraid of, either in the classroom or in the earth, because the earth survives. If it's given enough time, it can survive cataclysmic changes and restore balance. But that's also dependent on the fact that all of the elements are working together, that there is an interdependence between the biosphere, the human societies, the atmosphere, and as David said, now we are really influencing this at all times now, so we have to understand it. So these core principles of our cosmic education mean that the study of big history is absolutely essential, and Montessori talked about history as being the backbone of education. We have to understand these things. Further? Oops. Okay. And so we put geography, history, and biology at the core, not language and math, people. Biology, geography, and history. Looking at the world, understanding how the world works. So if you're making your yearly plan and you don't have lots of biology, geography, and history, and you have tons of language and math, you are not doing cosmic education, and you better start doing it. But it also means that we have to get the children out in direct observation of these things. They cannot be inside the classroom learning about them through nomenclature cards. They have to get out and touch and look and draw their conclusions and make their predictions and see if those are true. And we also have to have this storytelling. We have to be the ones to help them put it into a large context, because our first human communities, they really just had the first two. And it was enough to know about your local environment. It was enough to know what plants grew here, when the berries ripened on that bush, what kind of animals came to drink at that waterhole. That was enough. What kinds of stones were good to make what kinds of tools. But it is no longer enough. We have to tell the stories on a much grander scale to be able to put the child in touch with the whole. And then they've got to be able to work. So we have to have the materials with which they can do their own explorations, so they are not just dependent on our storytelling or on just their direct observation. So Montessori, at her time even, before as much science as we have now existed, she said that even at that time, to give the whole of modern culture has become an impossibility. And so a need arises for a special method whereby all factors of culture may be introduced to the 6-year-old. Please do not say, oh, well, you know, they're so small. They don't need to know these things yet. Yeah? They have big questions. They have big desires. They have a big imagination. We need to give it. Not in a syllabus to be imposed upon him or with exactitude of detail, but in the broadcasting of the maximum number of seeds of interest, and thus he may become an individual suited to these expansive times. Notice she did not say, look at me. She said, look at the universe, look at the child, help the child look at the universe. And so we are very lucky in Norway to have had the chance and the opportunity to develop a Montessori national curriculum. And it is based on this chart. And this is in the national curriculum, and you need to use it. You need to think about it. You need to base your instruction on it. It's really based on big history, because the first central stories are about the creation of the universe, and then the creation of life, the coming of humans, and then the two inventions with which we really started changing our environment, the invention of number systems and our written language. And that with those tools, we understand the rest. So Brian Swim, a cosmologist who's also spoken at a number of Montessori conferences and has written a wonderful book called The Journey of the Universe. And it's a whole series of, it's a whole course as well that you can take. Marie Montessori could see in a flash that each child must be educated so that she understands herself as part of an evolving universe, must receive what Montessori referred to as a cosmic education. The modern world could not grasp this at the time. She was ridiculed, especially when she came back from India with all of these ideas. Even in the Netherlands, where she had done a lot of research, made lots of materials, they said to her, we already have our Montessori. No thank you to cosmic education. Same thing happened in the United States. They took the materials that she had developed many years earlier and went their own way. And then when she came back and said, no, we have to think differently about that child from 6 to 12, people said, no, we have our curriculum now. We have our Montessori curriculum. And this we suffer from today, and the children suffer from that today. Because without this controlling vision, we don't really have something that will create the kind of education that we want for those 6 to 12-year-olds. So, if it required genius for this insight a century ago, is it possible that today more of us can begin to recognize its truth? Is it possible that our time is the time when the modern world grasps what Maria Montessori meant by a cosmic education and how vital it is that each child receive one? So I hope that many of you are here because that's what you want for the children, and that you have to then also convince perhaps the parents of your school that that is what they want, even though they may be thinking, and you even may have thought when you first got into this, that we will do that local thing that David said. We will do the disciplines. I will be a math teacher, but I'll just do it with some Montessori materials. That is not going to work. You have to get on board with this vision in order for those materials to come alive. This is a second story we have about the coming of life. And Thomas Berry, another author you should all take a look at, writes, "Intimacy with the planet in its wonder and beauty and the full depth of its meaning is what enables an integral human relationship with the planet to function." So it's not just about knowledge, is it? It's about an emotional attachment. What attached human beings to their place, the love of place that they developed in the first human communities, the love of their family, what caused them to be able to pass on this collective wisdom that allowed families to survive, cultures to survive, that intimacy, that emotional attachment has to be spread out. It cannot stay with the family anymore, or with the tribe. It is the only possibility for humans to attain their true flourishing while honoring the other modes of earthly being. The fulfillment of the earth community is to be caught up in the grandeur of existence itself, and in admiration of those mysterious powers whence all this has emerged. So we tell a story at the beginning of the school year, and it's a kind of a and so, and so, and so, and so story, just to get the chronology and to start to awaken some interest. We still, at 6 years old, have children who really do still believe that dinosaurs and humans lived at the same time. They pretend to understand when you tell them they didn't, but they actually believe that they did because they want it to be that way. And so we have to set the chronology. That is the first story. But that cannot be the only story. You cannot present that, leave it out, hang it up, and then say, my job is done, now let's get on with the math and language. You have to keep coming back to this. This is thousands of stories that you should be telling throughout your time as a teacher of elementary children. And that means you have to really also help them understand this idea of deep time. When children come in at 6, time is still a bit fuzzy for them. Now, if you say to them, hurry up, they may move slower because I feel really good when I move slow. I don't understand why you're so stressed out. They don't understand really age. They look around when somebody says, oh, how big you've grown. Okay, big must have something to do with age. And then they look at grandma and go, that's not seeming to work. Maybe it's wrinkles. Maybe it's gray hair. What's age? Children said to me, you have to be older than my parents because you're the boss. And I thought, okay, I'll be older than your parents. And I was like 24. But they also are trying to set things into a chronology. But they need some help, and they need especially help with this idea of deep time. As David said, our minds are not particularly able to grasp this notion. So when we talk about billion with the children in the elementary, we can't just say billion, we have to say billion. Because even if they have no idea what you're talking about, they'll go, oh, that must be important. That must be big. Yeah. And we can help them think about that. And then luckily we have our materials. We have at least 1 million cube, but we can't stop at the 1 million cube. We have to say, and then if we took 10 of those, how big would that be? And then if we took 10 of those, how big would that be? And then if we took 10 of those, how big would that be? And then if every single one was a year of your life, yeah. So we can help their imagination. We have a timeline of 4.5 billion years that we can roll out, and we tell the story from the beginning of the earth, and it's an and then story, just to give that 6-7-year-old a sense of that was a really long time, and the little red strip being that's how long humans have been on the earth. Now, the first black strip that was rolled out by Montessori was 300 meters. But usually 30 is good enough to get the impression across. And then we have a second one, when the children know more about clock time. We can tell the story again. Oops, I have to go back. To be patient here. This is our clock of errors, where we can see some more kinds of thresholds again, and the red strip being that 7 seconds or 21 seconds, depending on where you want to put the advent of humans, compared to the rest. And if you give that at the exact right time, around 7.5, when the children have, finally understood that clock, and then you said, now let's take that clock and make it a symbol of something else. Let's think of it in a different way. Let's think of our whole black strip being put into the 12 hours of a clock. Then you might get the response that I got from an 8-year-old who said, you know, our strip is very, very thin. But if we take really good care of the earth, it will grow in relation to these others. And I said, that is the goal. That is why I do what I do, is for that child at 8 years old to understand that. Now, we have also geography. And sometimes, and our geography is really about physics and chemistry and geology. And it's really about finding the keys. And when I was just recently did 6 hours on the timeline of life with a group of people just like you, 6 hours on one piece of material. We were looking at paleoclimate. What was the climate like at the different parts of the timeline of life? So that, because those pictures are just pictures on a white background. There's no ecology. There's no context. There's no energy flow being shown. That has to come from our storytelling. So as I was looking at those paleoclimates, this is what I found, and I found our geography albums. We found the Earth's orbit, that changes in the Earth's orbit changes paleoclimate. That's in our sun and Earth. We talk about how that special relationship has developed between the sun and the Earth, and how that had to be just right, Goldilocks conditions, to be able to sustain the life. And Yet, then the children also then need to know that has not always been exactly the same. The ellipse has not always been quite so elliptical, and that changes paleoclimate. The wobble also has changed, the tilt, and so seasons change. There hasn't always been ice at the poles. This is a very strange thing for the children to start to realize, because first you establish, okay, where are our climate zones? Yeah, and we have these Arctic zones in both, and then we go back and say, well, in the Cambrian there was no ice at the poles. And then why would that be? We have to go back to our geography, and we have to look at these different presentations that we have in our geography albums. We have changes in the distribution of the continents. We have a whole chapter on how do the continents move. We have the work of air, where we talk about land heating up faster and cooling down faster than earth, than water, which can explain a lot of what happened in the Permian times when all of the continents were stuck together. And we also have the work of air, where we talk about the ocean currents. That is changed when the continents are in a different position. We have the changes in the solar output. We have a story about the sun being born that matches what David said in his threshold about the stars. But the energy put out by the sun is also not stable. And then we have this atmosphere that we present in a very simple way early on, but we have to keep going back to it. And it's in our biology albums when we talk about the relationship of the leaf as a food factory for the plant, because the changes, the unbalancing and balancing of carbon dioxide and oxygen in the atmosphere is something that has always been taking place, because plants did not always exist on land. And when they did, there was lots of carbon dioxide in the air. They could grow to enormous sizes. But then there's a lot more oxygen being produced. That unbalances the system. And so when we go back to look at our timeline of life, we have to look at extinction. We have to look at when they happened and what was the ecology of those extinctions. In the Ordovician, when still there was only a tiny bit of life just starting to appear on land. At the end of the Devonian, when the plants were starting to really come alive. We see in our Carboniferous period that massive death of forests that produced that coal that David talked about is our energy source now, or those fossil fuels. The end of the Permian, and the end of the Triassic, and the end of the dinosaurs and the beginning of the mammals. All of those had to do with changes in paleoclimate. Some of them because of cataclysmic changes, like the ones from at the time of the dinosaurs, and some having to do with just the fact that any change, like the growth of plants, disrupts things and then might be the source of its own undoing. At the end of that story, we bring in the story of the coming of humans with their hand, their heart, and their mind, or we might say their movement skills, their imagination, and their hypersociality, all of which then combined to create this collective learning possibility. And I will recommend a wonderful book about that by Agustin Fuentes. He's a primatologist and anthropologist, called The Creative Spark. So all of that work about putting the child and the human being in this big context then has to be reflected in the way we put child into history in the classroom. And history, the human history part of things in the classroom, is not just about learning about other people and other times. It's also about learning about your own spiritual and physical needs, your own self-expression. Your art, music are part of our history curriculum. They are culture. They have been passed on from generation to generation. They are historical artifacts. The building the community of the classroom is just as much history as anything else, because these children face the same problems that humans have always faced. How do we learn to live together when we cannot read each other's minds? How do we create collective learning? How do we have goals that we all can work on? And a classroom that makes children follow individual goals, individual plans, is not a classroom that's going to create collective learning. It's not going to be a classroom where the children will share their learning. And it's going to be a classroom where competition will be victorious over cooperation. And then it's no longer really a human community. We also have to help them about putting themselves in time, because our modern society is based on these aspects of time, and then put them into contact with all the other people that have lived both before us and who live at the same time as us in the world. So this is our history curriculum, and there is no way to put that into a linear curriculum based on first grade children doing one thing, and then second grade children doing another thing, and then third grade children doing another thing. It all has to happen at the same time. Otherwise, collective learning will not take place. So the secret of our success as a species was our restlessness, was our inability to just let things be. And one of my other crushes, sorry, David, I had several. Edward Wilson, an evolutionary biologist, says, "Now to the very heart of wonder." Now, that's what our classrooms need to be filled with, wonder. Because species diversity was created prior to humanity, and because we evolved within it, we have never fathomed its limits. And as a consequence, the living world is the natural domain of the most restless and paradoxical part of the human spirit. We need to know about this thing that we're inside of. We need to get that top of the mountain picture of it. Our sense of wonder grows exponentially. The greater the knowledge, the deeper the mystery, and the more we seek knowledge to create new mystery. This catalytic reaction, seemingly an inborn human trait, draws us perpetually forward in a search for new places and new life. Nature is to be mastered, but we hope never completely. A quiet passion burns, not for total control, but for the sensation of constant advance. So our physical needs as a species, connected to our new abilities as a species, created also this restlessness. And we started changing our environment because we could. No other reason, really. We just could, so we did it. However, that does not guarantee morality. That does not guarantee that we should have changed it. That does not guarantee that there are not consequences that we are now then regretting. So there are two aspects of our evolution: those physiological things that allowed us to do these things, and then our hypersociality that then started to create this collective learning. So we were this hypersocial animal. We needed each other. We were an omnivorous animal, so we could eat anything, so we tried to eat anything. And we didn't just try to eat anything, we decided we would change how we ate things. We would cook. And once we started cooking, we don't seem to have ever stopped. And we don't seem to be ever satisfied with just cooking to survive or cooking to just do something in a minimal sort of way. We have, those, what is that, technological chemistry cooking things. And we were bipedal. Okay, that was good. Nature gave us that. But did we stay walking? No. We do parkour. We do football. We do ballet. There is no real need for any of those things. But we did it anyway because we could. And because something about becoming bipedal and being able to use our bodies in new ways, being able to use our hands in new ways, gave us such a thrill with ourselves that we just had to keep experimenting. We were a diurnal animal. We lived during the day. We developed our color vision like other primates. But that also meant that we slept at night, and that was a very dangerous situation. We were a threatened animal. We were prey. And our early ancestors really had to get creative not to get eaten. And so one of those things that got harnessed was fire, and that changed a lot of things. We also then became playful. We started to really do things just for the heck of it. And that also led to our creativity, because some of the things we played around with were really stupid, but then some of them were actually really good ideas and led to more ideas. We started categorizing things in order to think about why what we did was successful, how what we did is successful. We started negotiating with each other through different kinds of communication systems and eventually language. We also then just kept expanding our taste for new experiences. We became Epicurean. We started to be very gossipy once we got our language, and we created bonds through I know something about you, and I might tell somebody else, but it makes we know something about them, and that creates some kind of a bond between us. It's a kind of a grooming, like chimps do when they pick lice off of each other. And we also had to become compassionate because our children were pretty helpless, and we had to have many people raising those children. But our compassion did not stay, even in those early times, did not stay connected only to the family. We started having a connection to animals. We started having a connection to beauty, to abstract ideas, and we wanted to communicate that as well. And that also then turned us into a conflicted animal. We had competing desires. When you have so much going on, most of the time you are in disagreement with yourself or other people. And that puts pressure on the system. And this is our elementary classroom, people. These are the children. They are trying to figure that out. They are going to make a lot of mistakes. They need a lot of compassion for us. Their social, emotional development in this time is as important as their intellectual development, and we cannot keep pushing them into only thinking about subject areas when they really need to figure out about, say, friendship. We have stories then that we bring the children into contact with who they were as human beings, that every single child that is born today also had that ability to be as inventive as those first human beings who had nothing, who had to come to Australia and see giant birds and things and think, oh, I've never seen that before. What do I do? Is it food? Is it not food? Is it dangerous? Is it not dangerous? How can I adapt? Our children are adaptable. They are those people, and we have to tell stories of those unknown heroes who made tools because they could, because they needed to, and they kept perfectioning them because that's who we are as a species. And then we're not even satisfied with just telling oral stories and using language to connect with the people right around them. They started to write and send their thoughts out into the world. These are the stories of the unknown heroes that have to fill our elementary classrooms. Our stories of mathematics are the stories of those symbols we created just because we just couldn't help it. Our compassion, our interest, our creativity, at some point just had to have this symbolic way of communicating it. And Montessori writes, great creations come from the mathematical mind, so we must always consider all that is mathematical as a means of mental development. It's not about just learning to add, subtract, multiply, and divide. It is wondering about this idea of creating a number system that is so elegant that it only has one rule. When you get to be 10 of something, you exchange yourself for one of another category, and you move over a place. Well, we weren't the first people to think about that. The Babylonians also did. They just chose 60. We could have chose 60. We could have chose 20. Many people did. The children have to know that they themselves could have created a number system. They could have themselves created an alphabet. It would have taken some time. They would have had to sit there and talk to each other, say many, many different words, divide them into the sounds, think, do we need a symbol for that? I don't know. Is that symbol going to be the same for this other sound that is almost like that, but not really? But they could have done it. And they do it because they like to create secret languages, secret codes. So they're always thinking about their own creative ability there. Now, I have a good friend and former colleague who wrote a song, and it's to Jason Mraz's song, I'm Yours. How many people know the tune already? Hopefully many. No? We have a karaoke here, so that will help us with it. But to me, it's about fire, and I've tweaked the song a little bit. And I think that we have to remember that we also have to be that flame for the children. And what David said today, hopefully what I've said today, should make you bold, like fire made those first humans bold. And that gave them this Promethean power, this gift from the gods that then they used to create. Okay, so I'm going to say a line and you can say it back to me. I'll say it in rhythm. Actually, since I'm running out of time, we'll play it. You can sing along, then we'll do it again once you've gotten the hang of it and you're not embarrassed anymore. You can stand up. 1, 2, 3. wanted to capture your power, we held it. You lit right up a branch and held us entranced. We saw you as a gift, a divine intervention. Could never leave you be, gave you constant attention. Could never let you go dark. This sacred and holy spark, the flames, they made us strong, made us move on from dark and cold. Fire made us bold. Opened up our minds and saw that you could help us make our every dream come true. We looked into the flames and we saw heat, light, food, and listened to the music of the moment, and we grabbed the chance. You could lead us in this dance. We looked into the flames and we saw strength, creation, love. The flames, they make us strong, make us move on from dark and cold. Fire makes us bold, no need to stay one place. We can branch out, this is our fate. Fire makes us bold. Very good. Shall we do it again? Okay, how can I make it play again? How can I make it play again? Yes? Can I make it play again? No? Ah! Now? Down and from heaven we felt it. We wanted to capture your power, we held it. You lit right up a branch and held us entranced. We saw you as a gift, a divine intervention. Could never leave you be, gave you constant attention. Could not let you go dark. This sacred and holy spark, the flames, they made us strong, made us move on from dark and cold. Fire made us bold. We opened up our minds and saw that you could help us make our every dream come true. We looked into the flames and we saw heat, light, food, and listened to the music of the moment, and we grabbed the chance. You could lead us in this dance. We looked into the flame and we saw strength, creation, love. The flames, they make us strong, make us move on from dark and cold. Fire makes us bold, no need to stay one place. We can branch out, this is our fate. Fire makes us bold. Okay, so ironically, this fire, our then desire to burn things, is exactly what's kind of landed us in this mess that we have to deal with in the next 50 years, kind of, or else. And so it all comes back. The things that we discover, they can be our undoing, or we can have the good Anthropocene, We have a choice. But if we stay just teaching basic literacy and math and hold ourselves to sort of competensmål, bleh, huh? True competence is what we want. True knowledge and an emotional attachment that is enough to get these children off their video games into the world and making a difference. And we have to be the leaders in that. We don't want to just say, hands in the air, okay, we'll just do the minimum. Yeah? The minimum requirements are not good enough. We have to put big history at the center of our curriculum. Buy David's books, also one called Big History, excellent book, full of the stories you need to be telling. And so then we can really do what Montessori told us to do when she came back from India. Human consciousness comes into the world as a flaming ball of imagination. Everything invented by man, physical or mental, is the fruit of someone's imagination. We have to build that imagination in the children, not just as a way of being kind of personally creative, but encompassing that whole of history. So we have to remember the roots of those two important words for our cosmic education. Inspire, coming from the word to breathe into, to breathe life into things. And then enthusiasm. What do we want from the children? Possessed by the gods. We want them to be possessed by that passion for their world. Thank you.